Let me continue for the data modeling, results, and discussion. So in the first session, I'm going to describe decision tree regressor, which break the data into smaller parts in the three formats. The first step for the decision tree regressor is hyperparameter tuning. The parameter of complexity parameter is chosen to be tuned. It represents the size of the tree, and there are 10 values for the complexity parameter to be tuned. After running the tuning process, the best hyperparameter is identified, which is Cp equal to 0.0007. This parameter value can generate an R-square of 0.815. As when we further increase the Cp value, it started to drop for the R-square, and there is no sign for the R-square to be increased. So it double confirms that this value is the single best hyperparameter for decision tree regressor. Then we apply the best hyperparameter to visualize our decision tree. The maximum depth for the decision tree is 8, so the maximum number of layers is only 8. Then we want to examine which feature is the most important to predict our target total UPDRS. And we notice age has the highest value, which indicates that it is the most important feature in predicting and has nearly 4 times higher value than the second most important feature. Then we continue to apply our best hyperparameter to identify the training and testing errors. The R-square for training set is 0.867 and the testing set R-square is 0.831. The testing set R-square is slightly lower than the training set, which indicates that the decision tree regressor is slightly overfitting. Then we generate a residual plot of regression tree. As we can see, the residuals are distributed, tending to cluster toward the center of the plot. This indicates that it is a good fit for regression. In the second session, I'm going to describe the random forest regressor. The first step for the random forest regressor is to tune the hyperparameter. The hyperparameter to tune is M3. M3 is the number of variables that will randomly sample as candidate at each split. The values to be tuned for the parameter of M3 is 2, 3, 4, 5, 6, 7, 8, and 9. After running the tuning process, the best hyperparameter is identified, which is M3 equal to 8. This value can generate R-square of 0.893. As we further increase the M3 value, the graph here shows that it started to drop for the R-square. So this double confirms that this M3 equal to 8 is the single best hyperparameter for the random forest regressor. Then we also visualize error against number of tree. When number of tree from 0 to 50, the error drops significantly. And when the number of tree from 50 increased to 500, the errors only drop slightly. It has an inverse relationship between error and trees. In our model, 500 trees is chosen because it has a lower error rate. We continue to apply our best hyperparameter to determine which feature is the most important in predicting our target. Similarly, age is also the most important feature. For the random forest regressor, we also want to examine the training and testing errors. For the R-square in training set, it has 0.983, and for testing set, R-square can generate 0.912. In comparison for all models, random forest regressor has the highest R-square and the lowest RMSE and mean for both training and testing sets. Residual plot of random forest regression is also generated. As we can see from the graph, all the residuals are distributed and clustered toward the center of the plot, which means that it is a good fit for regression. In the last session, I'm going to describe the best performing model. In this table, we can see for the R-square for random forest has the highest, which is 0.983 and 0.911 for both training and testing set respectively. And for the RMSE, random forest has the lowest RMSE for training and testing sets. Similarly, for the May matrix, random forest also can generate the lowest May for the training sets and also for the testing sets. As a conclusion, Watts measures have a nonlinear relationship with UPDRS. Therefore, 3 nonlinear models are deployed in our experiment, which are support vector machine, decision tree regressor, and random forest regressor. Random forest regression model can best predict UPDRS based on Watts measures. And also, H is the highest feature importance in the prediction of UPDRS. And overall, we successfully built a predictive model that can accurately predict the total UPDRS score with at least 0.9 R-squared. And our aim in this project is achieved. Thank you very much.